Hey guys, and welcome to a new video in this C++ tutorial. In this video we're going to talk about pointers and references and like what it is and what they can be used for. Like first of all, if this is the first time you're seeing pointers and references in coding, it might be like a bit abstract and it's pretty like hard to get an like intuitive overview over like what pointers and references are and what it can be used for. But I'll try to explain it in a like nice and good way and give you an introduction to what it is, and then later on we'll go into code and show you some examples of what it can be used for. So like, why are pointers and references important in C++? Because they can improve the performance of the program significantly, because we can like optimize our memory and also like the time, so like the time the programs take to run. So it makes our program way more efficient to use like pointers and references, and we're going to see some examples on like why it's important and how it increases the performance of our program. We can also say that like pointers and references are arguably like the most important thing in C++, because like it is just one reason to choose C++ over another language, because we have pointers and references which we don't have in Python and Java, which also like makes C++ stand out from the other programming languages like Python and Java, because we can use pointers and references and we're like really close to the hardware of the computer, so we can like manipulate the data directly in the computer's memory by using pointers and references to some memory address in the memory of the computer. So we can like, we're really close to the hardware here, and it's just another benefit of C++, and like it's an abstraction from C, and then it's built on top, like C++ is built on top of C, which is like also really close to the hardware. So with pointers and references, we're able to get close to the hardware, point to some memory places in the computer, and then we can do some modification or manipulate the data that is stored at those addresses. So first of all, we're going to talk about like what references are, and a reference is just like the word describes, is just a reference to a variable, in this case in the code here. So when we're using references, we use this ampersand operator here, which is also like the AND operator. So when we call this operator here in front of our variable, it will be a reference to that variable, and that line of code, like the AND operator here, and then the variable name, it will return the memory address of that variable, and then we can do something else with that, compared to if we just like call the variable, it will make a copy of that variable, and then we could then it will store the variable twice in the memory, and then we will do some modifications on the other variable that is now stored, and it takes up twice as much memory that if we just had a reference to that variable and we modified our variable or data directly at the memory address, because we're using this reference operator here. So like, what can references be used for? And as I just said, like if we have like some functions, we can like modify the parsed arguments in a function. So if we, for example, have a swap function, we can like just modify the two arguments where we just swap those two elements, which is like equivalent to swapping the two memory, like the data or values that are stored in one memory address. So we just swap these two values at those memory address, we just swap those, instead of creating copies of our data and just messing around with our memory, and it makes our program more inefficient. And we can also like avoid copying large data structures. Let's say we have like, for example, a function where we parse an image, or like some big matrix, or like just a really large vector, or like any other data structure, and we pass it by reference, then it won't copy the whole argument we pass to the function. It will just make a reference to that variable that is stored already in the memory. Because if we didn't pass it with a reference in the function, it will just create a new copy of that. And let's say we have like an image, and we just pass that image to our function, then we'll create a copy of the photo, and it will take up twice as much memory. And we can see that like if we call this function a lot of times, or we do some kind of other operations, and we just keep copying the same image, like in the end it will just like take up so much memory, and that our program will just be like really slow and very like inefficient memory wise. So it's really good to like modify arguments that pass by reference, and avoiding copying large data structures, and also those like smaller data structures. So it's a really good practice to use references when it's possible in functions, and also like elsewhere in the program. So down here we can see that we have a reference here where we have like an integer, not and the variable num, a variable name here num, and the value here is equal to 10. And then if we call this AND operator here, like, or our reference operator, it will then return the memory address here. We can see down here, of like the memory address where this value 10 here is stored. So instead of like calling the num here somewhere else in a program or passing it a parameter, we will then like call this memory address here and then modify the value that is stored on this memory address here. So pointers. So let's head up towards pointers now, and like pointers is like a bit better than references, and like kind of like the same purpose, where like pointers, they point to the memory address. So like the reference is just like referring to like some memory address, but when we have a pointer, we can have like a pointer that is pointing to that exact memory address where our value is stored. So it also like says here that the pointer, it stores the address of the variable and then like the memory address of the variable. So you can see here over here to the right, we have an example here of code where we have a number here that is just like a variable and an integer that we assign the value 10 to here. And then we can create a pointer, an int pointer here, that is pointing to the memory address of the variable here, because we are referencing the variable here in number. So it will not return 10 in this case here, but this reference here will return the address of the memory, like the address of the memory address where this value up here is stored. And then we will store that address in the pointer here, so that pointer will point to the memory address where this variable 10 up here is stored. So it can seem like a bit complicated in the start, and if it's the first time you see this, but we'll go more in depth with it, and I'll show you some other different kind of examples in code where it might be a little bit more intuitive, or else we'll go more in depth with it in other videos and like see like how we can use pointers. But it's a really good thing to like know about pointers and references when we're working with C++, because it is so like important and makes our program much more efficient. So it's really good that you just like keep on trying to like learn about pointers and references, and just, even though it doesn't really make sense now, just keep watching videos and like gaining the knowledge about pointers and references. So over here to the left, like it is like how pointers work in C++, where again we have this variable up here, which is like equal to 10, we are initialized over here. So this will be the value of the variable, and if we want to access the variable here, we need to dereference the pointer to access the value that the pointer is pointing to. So in case here we want to get this value here from the pointer, we need to dereference it with this star symbol here, and then the pointer that is pointing to that memory address. So here we have the pointer here, which is like, and we have the address of the variable stored here in the pointer, and then that pointer here, like, and then under here we have the address of the pointer variable, which is the pointer we initialized over here, which is like pointing to this address here of the variable. So this address variable here, it stores this number. So if we want to access this number here, we need to like dereference the pointer here, and this pointer down here is pointing to this variable, and then we dereference it to access the value here stored in the address of the variable. So if we want to get the exact value, like the cout over here will just cout the address of the variable, but then if we dereference it, we will actually get the value at the address, and then we can do some modification of that data here when we have dereferenced our pointer. So one of the last examples here, like when we like try to compare the pointers and references, where over here we can see that pointers, they store an address of the variable, where like references, they refer an existing variable. And pointers, they can have a null assigned to it, so you can assign a pointer to point to null, so it won't point to anything in the memory. So where we can't do that in with references, because like we can't assign null to it, because it like needs to be initialized with a declaration as I wrote down here. And with pointers, we can pass a pointer by reference, like pointers that passed by reference, where references, they are passed by values. So we need to like parse, when we're using references, we need to pass that with values as we saw here on the first slide. With pointers, it is not necessary to initialize it on declaration, where when we're using references, we must initialize it on declaration, which like means that we can assign null to it. So it needs to like have some value that we can like at some memory address that we can reference all the time in the code. So it must be initialized on declaration. And also like pointers, it has its own memory address and the size of and its own size on the stack, where like references, they share the same memory address with the original variable. So we can have, like as we saw in the sample here, we have the address of the pointer variable here. So there will both be an address of the pointer variable and also like an address of the variable, where the references, they have the same memory address. So we can just like take the reference to that address and it will give the same memory address here. But it also takes up some space on the stack. So in C++ we most often use like smart pointers, and I'll make a new video on smart pointers because it's a really good thing, because there's some small problems with normal pointers in C++ because they're not deallocating pointers and objects when done using them. So when we have initialized our pointers and when we're using them and we don't delete the pointers after like we're done using it, it will just like cause memory leaks, which in the end will cause the program to crash in the end, because if we don't deallocate our pointers, it will just like accumulate in our memory, and then at some point our memory just like it takes up so much memory and there will be memory leak where we can like access the pointers again. So they will just be like still stored in our memory, but we can't access them again because somehow it messed up, and it will cause in the end the program to crash. So like to avoid this, we can use the smart pointers, which is a built-in pointers in C++, and I'll make a new video on smart pointers because they're like, as the name says, they're really smart, because like they automatically manages the memory, and it also like deallocates the objects or like the pointers when they're not in use, which means that like the memory where the pointers are stored, it will be deallocated when the pointers go out of scope. So let's say we have like a function where we're using some pointers. When we're using some pointers, and if we use like normal pointers and we just go out of that function without deleting or deallocating our pointers, they will just like cause memory leak. But if we're just using smart pointers and we go out of the scope, it will like automatically get deallocated from memory, and that's a really like cool thing with smart pointers. There are three different types of smart pointers here, which is like unique pointer, shared pointer, and weak pointer, and there's some different kind of differences between those three, which I'll go more in depth with in another video, or like probably the next video, where we're going to see some examples on differences between those three pointers here. And like most of the time we need to use smart pointers compared to like normal pointers, because it makes like the program much easier to work with, and also like it would automatically like take care of the memory. So that's a really good thing. And yeah, just let's jump into Sublime Text and see some examples on like the pointers in C++ and get like a better overview, or like how we can use them in our actual program and how they work. And then in the next video we're going through smart pointers and see how they work in C++. So we're now done into Sublime Text here, and I'm going to show you some different kind of examples of like how we can use pointers and references in C++. So first of all, here we include the standard library up here in the top, because we're going to use some of the functions from the standard library. And then we have like created a class here that we're going to use later on, where we have where we can also use pointers and the pointers to like create a class. So we have a class that is initialized as a pointer, and then we can do pointing to the member like the member attributes or member variables of that class here. But that's in the end of the video here. So first of all, just starting with the basic things where we want to make a reference to a variable. So we just start with creating a string variable here called name, and then we assign the coding library string here to the name variable. And if we just want to like, first of all, we want to see out like the name here, and we hit Control B, it will just print out the coding library as we know in original C. But if we use this reference operator here and to the name, we know that this will return the memory address of where the name is stored here. So if I hit Control B again, we can see that the coding library here is stored, like it begins at this memory address here. So this is the actual memory address in my computer where this string name here is stored. So this will be a reference to the name variable here, and this reference name here would contain the memory address memory address in my computer. So if we want to do some modification on the name here, we can do that with this reference operator here, and we're going to do that as well. But if we just take an example here with pointers in C++ and how they work, then we can see here that we can have a pointer that is pointing to the like the reference of the name here. So the pointer will it will point to a memory address of the string, like where the string is stored, because we have this reference name here. And we declare a string here with this string, and then this this star symbol here, and then we give our pointer a variable name. So if we go down here, we'll just do some different kind of modifications with our pointer now. And first of all, we're just going to print out the name as we did in the previous example, and we're going to see out the reference to the string as well. And then we just see out the pointer to the memory address where the string is stored. And then afterwards, we will dereference the pointer to access the memory address, and it will return the value that is stored at that memory address. So if we hit Control B here, we can see that. If we just make this a bit bigger, first of all, we see out just the string here, the coding library, and then we print out then we see out the reference to the name here, and we also see out the pointer. And we can see that these two are equal to each other because we made the pointer up here point to the reference of the name here, or the memory address. And then afterwards we will then dereference our pointer where we will get our actual value that are stored at this memory address here. And then we could have done some other operations with our dereferenced pointer here, and at the actual memory, the actual data that is stored at that memory address here, which our pointer is pointing to. So if I just comment this out again here, we have another example here where we want to modify the pointer values. So we can see that here we want to first see out the dereferenced value here, or the dereferenced pointer, and then down here we want to change the pointer the value that the pointer is pointing to, and we just change the string here to pointer changed, and then we just print out the new value the value that is stored at that memory address where the pointer is pointing to by doing this dereferencing. And then we have this name here we just print out. So I'll just hit Control B here, and we can see that first of all it prints out the red thing here, and then we change the pointer here with this dereference operator here. We print it out, and then we can see if we print out name here again, we will still get the memory address where this string is stored, and we can see that it is still at the same memory address as the last string that was stored up here, because we're using the same memory address, because we're using this pointer here that is pointing to the memory address of the name variable here. So if we didn't use pointers and references to memory addresses, and we changed the string values here, it could have been stored somewhere else in the memory, or created a copy of it in some way, and it will mess up our memory a bit. But in this case here, we just operate with one memory address, or in our computer's memory. So it's a really nice and cool feature, and we're really close to the hardware compared to we are in a high level programming language. So down here we have the reference here to the name, and it will again then print out here the memory address, and then we change the name variable here to high, and then we just print it out again, and we can see that it will indeed still change it to high here, because this name variable here is changed to high. So we can also use classes and pointers. We can either use dot or and arrow operator to access the members of the class. We're going to talk about object-oriented programming and classes later in this tutorial, but I just want to give you a quick overview over what pointers and classes they can be used for, and it's a really a really cool feature when you have classes and you want to point to some of the class's member variables or attributes. So we created this class up here called employee, and it has some public members up here, member variables, and we have a string called first name, and then we have an age here, which is an integer. So down here in our class, we need to initialize our object, which is an object of this employee class here, and then we can access the members of this object here with this dot operator here. So we can say here that this object emp, which is an employee, we want to set the first name of the employee here to decoding. And if we see this out, I'll just comment this out of here first, so it doesn't mess up. So if you want to print this out here, I'll just hit Control B. It will print out the coding, because now we have changed the member variable of the employee here, the first name of the employee here, to the coding, and we just print that out here. So this is a way we can use, like we can modify variables inside of a class with this dot operator here. But if we were going to use pointers for objects and classes, which is like really useful as well, we can use this arrow operator here to access the members. And first of all, we need to declare an object here of a pointer. So now our employee will have like an object which is a pointer, and then we need to like have the pointer employee2 here and set it equal to a new employee, because we need to like use this new keyword here to allocate some memory for this new employee here that we are declaring as a pointer. So now when we have a pointer object, we can use this the arrow operator here. So now M2, it will like this arrow operator here will point to the age, like the age member of the employee 2 here, and then we can set that age equal to 20. And if we print that out, we can see that indeed it will print out 20, because we have modified the age of the employee 2 up here to 20, because we have this pointer that is pointing to the age member here of the class, because we have a pointer object up here. So if you're using the original or like the standard pointers in C++, and we're not using smart pointers, which we're going to talk about in one of the next videos, because like they're as the name says, they're smart because they can deallocate themselves. But if we just want to like delete the pointers here in C++, if we don't use smart pointers, because we have to delete them, or else we will just leak the memory and we can't access them. It will just accumulate in our memory, and in the end our program will crash. So first of all, we need to declare our pointer to assign the null here to our pointer. So the pointer here would point to it will point to like somewhere in the memory, and then when we assign the null here to our pointer, it will just like point to nothing. It will just like point to null or like 0, and then afterwards, when it's not pointing to anything, we can then delete our pointer here. So if we try to like delete it without having this null here, we could do that, but then it will cause some leaks, because that pointer would still point to somewhere else in the memory, and we can't access that memory ever again in the program, because we have a pointer that is deleted, but that pointer we can't access that memory address again, because some pointer was pointing to that memory address and we didn't delete it, and we just deleted it, so we can't access it again. So we need to declare to like, or assign it to a null like pointer first, and then we can delete the pointer here. So if we see it out here, we can see that before we deleted our pointer, it was pointing to this memory address here, and then we pointed it to null, and then we deleted our pointer here, and after that we can see that our pointer is deleted and it doesn't like exist anymore, and pointing to 0. We can do the same here for our object pointer here, or like our object pointer here, where we just first set it equal to null, and then we can delete our object here. So we need to do this every time we go out of scope, or we don't use our pointers anymore. So it's not really that good, and sometimes you just forget to delete a pointer, and if you're using a lot of pointers, it's just like it just makes up a mess. And when we're using smart pointers, we don't have to do this at all. It will just automatically do like these lines of code when they go out of scope. So it's really efficient, and also makes the code shorter and more readable. So smart pointers is a really nice feature, and also just like pointers in general, because they can be used for a lot of different kind of things, and it also just increases the performance of our program and the memory. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification on the video, and also like this video if you like the content and you want more of it in the future. If you want to like use C++ when you've learned it for something else, or like some more practical things, I'm also making a computer vision tutorial, and with OpenCV and also algorithms and data structures tutorial where we're talking about different kind of data structures and algorithms that can be used. So if you're interested in one of those, I'll link to that one of them up here, or else I'll just see you in the next video, guys. Bye for now.